Okay guys, we're going to go on with example 3. This time we are going to use our calculators. I'm going to use Desmos. You can use your graphing calculator if you would like. So example 3 says, given this polynomial, we're going to find the relative max, relative min, and then we're going to do domain and range, and then we're going to talk about increasing and decreasing intervals. So what a relative max or min is basically the highest point on the graph within a given domain. So your relative min would be the lowest point on the graph within a given domain. Now, there's another term called absolute max and absolute min, which means the absolute highest the graph would go or the absolute lowest that the graph would go. So the first thing we want to do is we want to graph this function. So I'm just going to go over to Desmos here, put our function in real quick. And then I'm going to do a little sketch of the graph on my paper, just so we can give ourselves some notes of what we're looking for. So in this case, it's asking for the relative max, relative min to the nearest 100. So within this given domain, if you look over here on Desmos, this is going to be my relative max. This is going to be my relative min. This graph does not have an absolute max or an absolute min because it's going to positive infinity and negative infinity. So neither would be an absolute max or absolute min. So I'm going to just jot these points down. On my sketch. So I've got those for my notes. And for your max and min, you want to use your y values. You could write the whole coordinate if you wanted, but in this case, I'm just going to write the y values. So our relative max, I'm going to abbreviate, is going to be at the y value negative 0.73, and our relative min would be at the y value negative 5.42. B asks us to state the domain and range of this function. So domain is your x values. So as this function, yes, it's going down forever, up forever, but as it's going down, it's getting wider, and as it's going up, it's getting wider. So it's going to be all real numbers, negative infinity to positive infinity. And then our range is going to be the same for this graph. So just to refresh your memory, x values, y values. So then it asks us to state the intervals the polynomial is increasing and the intervals that it is decreasing. So for the intervals of increasing, I like for my students to think of positive slope. And for decreasing, think of where you would think of negative slope. And we're only going to use x values here. So if I look at this part of my graph, or if you want to come over to Desmos and look at it here, this would be positive slope, okay? So we're rising, going up a hill. Think of it that way. So the x values, I would start at negative infinity. And back over to Desmos, we're going to rise all the way to this turning point. So at this turning point, my x value is negative 2.72. Okay, then we're going to have this little section with negative slope. So I'm going to go here and write decreasing. So the x value at this turning point again is negative 2.72. And we're going to decrease or go downhill to the x value of negative 0.61. And then I have this turning point again, and I have positive slope again, or I'm going up a hill again. So the x value, we're going to put union and. So x value at my turning point again is negative 0.61, and then that will go to positive infinity. So 2 places for increasing. Okay, next is a your turn problem. You can pause the video and try this and then compare to my answers. One thing I do want to point out is it asks for a relative max. There is not a relative max, okay? There's not an absolute max either because both ends are going to infinity. It does have an absolute minimum because this is the absolute lowest this graph will go. So that's the difference between relative and absolute. So you can check your answers to that and hopefully you get those correct. We're going to go on to example 4 where we're going to work backwards from the graph. So they give us the graph and we are going to write the equation of this cubic polynomial. Actually guys, I think I'm just going to pause the video here and we'll start back up.